So Frisbee is a game played with one of these plastic discs when we have 7 versus 7 people playing outside on a grass pitch. It's sort of a mix of various different sports with rules like American football mixed in with some sort of basketball things, a little bit of football as well. But essentially, there are 2 teams playing against each other and they're trying to advance the disc towards opposite ends of the pitch where they can score a goal. So as a physicist at the Cavendish Laboratory, I'm very interested in learning about how science, especially physics, applies to the real world. So when we throw these Frisbees in the game, there are a lot of different physics concepts that govern the path of this Frisbee going through the air. And the first one that I want to talk about is lift. So when this Frisbee is flying through the air, it typically has some sort of angle of attack. So maybe it's angled like this, maybe much higher, maybe sort of more flat like this. And the different angle that you give it here helps the Frisbee generate lift. You can sort of see that the Frisbee has this curved shape, just like an airplane wing. And much like a wing, when it's going through the air, there's air that is deflected downwards when it hits the Frisbee. So it goes like this and then goes downwards. What that means is that the Frisbee is pushing the air down, and you can sort of see on the top of the disc too, the air is going to go over and down. And what Newton's third law says is that every action has an equal and opposite reaction. So if the Frisbee is pushing the air down, the air pushes the Frisbee up, and the Frisbee has lift. So that's how the Frisbee stays in the air longer and goes upwards. But inevitably, at the end of the day, that's counteracted by gravity, which brings all things down.